looking at part two of related rates. Okay, so in part one, we looked at how we actually do the derivative. Now we're ready for the word problems. Okay, so for my first example here, I'm looking at MP3 players. We're looking at a nice formula for our demand function, the quantity versus price. And so looks like currently we got a price of $40. It's decreasing at a rate of $1.50 per week. And so we're asking the question, how is quantity of demand changing with respect to time? So that's our situation. Now, first step in doing a word problem like this is I want to identify my goal. I want to identify what we're looking for. And typically in a math question, you're looking at the last sentence. That's usually where it is. And so in this particular one, when I'm looking at that last sentence where the question is, I'm seeing some keywords. I'm seeing quantity. That's a keyword for me. Changing, because I'm seeing the word changing. That's that dynamic kind of thing. I'm thinking rates of change. So I'd be thinking derivative somewhere along the line. And then with respect to time, so what I'm looking at here is I'm looking at the derivative of quantity with respect to time. Okay, so that's what I want to find. I want to find a rate of change, quantity in terms of time. So like a dq over dt kind of situation. Okay, step number two is what information do we have from the problem? We want to make sure that we have that listed and understand what's going on there. In this particular problem, we were given the formula for demand. We're also given a little bit of information. We have price is currently at $40, so I got P equals 40. That's a piece of information. We also have prices decreasing at a rate of $1.50 per week. So I'm looking at dP dt. Because that's a change in price, not with respect to quantity. We're not talking per quantity, it's per week. And the per word, that per word, you want to get used to that. That's really the word right there that's telling me rates of change, and it's telling me how to set up my fraction. So I'm looking at price per week, price per time, so that's why I got that dP over dt. I got my price on top, and I've got my time, which happens to be in terms of weeks this way. And we're decreasing, so that's why you're seeing the negative 1.5 there, because we're decreasing that. It would be a negative rate. Let's see, that does our information there. So step three, I'm just kind of start brainstorming my relationships. What do I have to play with? What I'm going with? I've got my formula for demand up there. I know that my goal is to make a dq over dt. That's what I'm looking for. That's what I want. I want a nice formula. And then I also have in the back of my mind, oh yeah, remember when I'm doing the power rule, that with related rates, when we do the derivative, and we've got a different variable down there than what the formula is made of, then basically we got to remember we'll have this extra component from the chain rule. So when we're doing the derivative with respect to a variable and we have a different variable in the formula, we've got to incorporate this little extra piece for our derivatives, that dx dt part in this case. We got to take the derivative of that variable. And so now my strategy here is basically what we're going to do. We got a demand function. We want to find dq dt. Basically, we're going to take the derivative of that demand function, and then we're going to plug in the numbers that we have, crunch it out, calculate it, and we're basically done. So it's going to be a nice short little process here for this one because the formulas that we have are all ready to go for us. Okay, so now I'm ready to do my steps, and so I've got my demand function. I want to do the derivative. I want to do the derivative with respect to time. So I'm looking for dq over dt. So I'm looking for doing the derivative in terms of time. So when I do this, the derivative of 3p straight up, just like I do my normal derivatives, the derivative would be 3. So that's why you're seeing the 3 there. But also we have that dp dt there. And so the derivative of the variable itself. And then for the second piece, the power rule says take that 2, bring it down in front, multiply. That's where the 0.2 is coming from. Subtract 1 from the power. So that's why we have a p to the understood first power. And then again, the next step is to take the derivative of the variable itself when your variables are not matching up, when they're related. So we've got a relationship going on here. Quantity and price are related in terms of time. So time's a relationship here. That's why it's a related rates because we start with the formula with Q and P, and we're actually doing the derivatives in terms of a different variable. Okay, and so now that I've got my derivative ready to go, all I need to do is just plug in my values. So we had, you may recall, our change on price was decreasing at $1.50. So that's, I'm plugging in the negative 1.5, and then our price was 40. I'm just putting those numbers in, crunching it out. I got $7.50 per week. And so our change in quantity each week is $7.50. Now, some people don't like that it being a decimal there because they're thinking, hey, dude, quantity, how can you have a half of a quantity, you know, the units kind of thing. Well, if that's the case, what you have is you can actually modify the time frame. So instead of doing per week, 7.5 per week, you can then put it into whole units and say, oh yeah, we're going to have 15 per 2 weeks. And so you've got that case in the business world that if one rate's not working because the decimal doesn't make sense, go ahead and change the time frame so that you get some nice whole numbers, and then it will actually make some sense. Okay, so this is an application of an example of doing related rates. We're having formulas, and then we're doing the derivative in terms of a third or fourth different variable in that case. All right. Hope this was helpful. Talk to you on the next one. Thanks.